All right, we're going to take a look at the unit circle, and we're going to see how we can use triangle similarity to find missing lengths and find out, say, the height of the Comcast tower here in Philly. So the first thing I'm going to do is I'm going to start by graphing in my unit circle a 70-degree angle. So I'm going to take my protractor, I'm taking the pin or the circle, the little hole, I'm going to make sure that goes on the origin or where the x and y axis cross. I'm lining up the bottom line here along the x-axis, and I'm making sure then that the y-axis is also at 90 degrees. Once I've got that, I should be in good shape to make my 70-degree angle. So I can just use the inside track right there if I want. None of these angles are going to be anything other than multiple of 5 or 10. So now that I've got that mark right there, I'm going to create my 70-degree angle. Now, what I've done is I've created the hypotenuse of a triangle, and I'm going to go ahead and now find out what the B side, if you will, this leg of my triangle is, as well as this leg of my triangle, the x-axis. So one thing we can do is we can kind of see on our own that this guy looks like it's somewhere between 0.9 and 1. So the y value here should be somewhere between 0.9 and 1, and it looks like the x value is somewhere between 0.3 and 4. Here's how you can learn what the actual value is precisely. In your calculator, you're going to make sure, after you go into mode, that you are in degrees. Excuse me, right there, and hit enter if you need to. Once you're in there and you want to get out, you can hit second mode, quit back out, we're at the normal screen. And I'm going to put in, for this value, the height of my triangle here, the y value, sine of 70. And if you get a negative answer or something weird like that, you're probably in radians, but this answer is good. And hopefully you can kind of see how that 0.939, if we were to round this, would really be 0.94, but we'll call it 0.939 for now. You can kind of see how that 0.939 should be right in here, right between 0.9 and 1. So hopefully you can see how that value makes some sense. I'll just do 0.939. We're going to just not round there. All right, and now let's go ahead and let's find out what the x value is. We use cosine for that, cosine of 70. And here we go, 0.342. 0.342. Hopefully you can see I'm just over the 0.3, between the 0.3 and the 4, so this 0.342 should make sense. Excellent. So what I've done is I've found my trig values, 0.342, for x cosine of 70 and y, the sine of 70, all right? And now I have this triangle that has a side length of 0.939 and another side length of 0.342. Awesome. Well, those are going to help me when I want to basically dilate or expand out, scale out this triangle to now have the same height as the Comcast Center. So let's see which sides correspond to which in this particular situation. This 0.342 side seems to correspond with the 354.5 feet on this triangle down here. And then this value, the 0.939 value, seems to correspond with the one that we don't know, the height of the Comcast Center. So I'm going to set up a ratio, which we're going to solve using cross multiplication or butterfly method. And I'm going to keep these guys together in the same fraction and these guys in the same fraction. But the way I set it up is really important. So I'm going to take both short sides and put them on the top of the fraction, and both long sides, they're going to go on the bottom. So here's how I do that. I'm going to put 0.342 over 0.939. All right, so again, that's the short side, that's the long side, and I've kept them in the same fraction. That's going to be the same thing as the short side over here, which is 354.5 over the long side, which is our x, my unknown quantity. After that, I'm going to do a little bit of algebra. I'm going to multiply those guys together and 0.342 by x. So I'm going to have 0.342x equals. Now let's go ahead and multiply 0.939 times 354.5. And I've got 332.88. Let's round that to 0.8. All right. So 332.88. All right. So with a little bit of rounding, I'm just going to bring this to two digits, 0.88. All right. So that's not our answer. It's just a means to an end. I'm going to divide both sides by 0.342 now, divided by 0.342. And when I divide by a number that's between 0 and 1, I'm going to make my number bigger. So we should get a number that's larger than 332.88 when we solve this guy out. So 332.88 divided by 0.342 is going to leave me with 973.3 feet. Nice. So it looks like our value, x equals 973.3 feet. And that's actually really good. That's the same height as the Comcast Center. So 973.3 feet. Perfect. So that's, what did I just do here? I used the same triangle that I made up here in my unit circle with the two values, or the lengths of this leg and the length of this leg, set up in a fraction like we have down here. And I've said, okay, cool, well this side compares to this side. The 0.342 compares to the 354.5. So those guys should both be in the numerators of their respective fractions. And then the 0.939, that one relates to the feet, the height of the building that I don't know. So I've set up my ratios. I kept these two guys in the same fraction. I kept these two guys in the same fraction, and then I went ahead and cross-multiplied to get to 973.3. All right, so what this one's asking us to do is graph this 45-degree angle, but then carry over the answer that we have from the first one, 973.3. And that's going to be the height. All right, so that's my height of my building. Now I want to know how far away am I standing. So I'm going to graph this 45 degrees. And 45 degrees is an interesting one when it comes to trig. So 45 degrees is basically the number that everything is distanced from, if you will. It's the smack dab in the middle, and you can kind of see I've got the same distance going from 45 down to 0 as I do from 45 up to 90. So if we talked a little bit about this in class, if I had, say, like 50 and 40, all right, the values on my trig unit circle here would just get flipped because they're the same distance from 45. If that didn't make any sense from you, don't worry about it. But we talked about that in class a little bit. So here's my 45-degree angle. Let's go ahead and see what it looks like the values on my triangle look like. They might be. There we go. So looks like it's just above 0.7 for both of them. And it looks like they might be the same. Let's just go ahead and let's find out if that's the case. So I'm going to do, first I'll do sine, so I'll find out what the y is. Sine of 45, 0.707, cool. All right, that makes sense, it's just above a 7, so 0.707. And let's do cosine now, 45. Hey, interesting, it's the same thing. Interesting, okay, 0.707. All right, so that's fascinating. What is that going to tell us? Well, we have the short and the long, if you will. They happen to be the same, but we'll just assign one as short, one as long. They're identical, I get that. But so the top and the bottom here on this fraction I'm creating in order to solve out for the length, the distance I am from the building, well, 0.707 over 0.707 is going to be the same thing as this side, which we'll call that, because it doesn't really matter, but we'll say this one is this one is this one. So equals 973.3 over x. Let's just pause for a second. What is 0.707 divided by 0.707? 0.707 divided by 0.707. Hopefully you all know what this is going to be, but 1, right? So if this guy simplifies to 1, what would I have to divide 973 by 0.3 to get to 1? The same thing, right? So this guy has to be 973.3 because every single time I've got a 45-degree angle, both sides are going to be exactly the same. So let's think about this for a second. This 45 degrees right here, all right? If I were to make that angle bigger, then this side would have to get longer as that angle got bigger. Same for this. If this guy were to get smaller or bigger, right? If the angle got smaller or bigger, it would affect the other side. So if this side is 45 and this side is 45, that means that both of the corresponding sides, or those angles I should say, were 45, both of these corresponding sides, all right, this 45 belongs to that side, this 45 belongs to this side, right? Because this 45 affects how big this side is, this 45 affects how big this side is. If they're both 45, they have to both be the same, all right? So that's a fun little thing to notice whenever you have a 45-degree angle. Both legs of the right triangle are going to be identical. All right, we're going to wrap it up there.